Hey guys, we're back with another video here. But first, before we begin, I would like for you to find this missing length. So pause the video now, go through your work, write this down, and find this third side of the right triangle. Okay, how'd you do? So we know we're using the Pythagorean theorem here. So we have our hypotenuse is unknown, so we have 14 squared plus 16 squared, and working through the math, we get square root of 452, which is approximately 21.2603, and when in doubt, we round to 4 decimal places. So this leads us perfectly to our next concept within this unit when we talk about general triangles. So we have just come from law of sine and law of cosine, law of sine, and in this video, we're looking at law of cosine. And what it does, what it says, we first examine just a general triangle with our ABC, and then our lowercase a, b, c. And what the law of cosines says that if I desire to know the length of C, it states C squared equals A squared plus B squared. That probably looks very familiar. And then we extend that to minus 2 times A times B multiplied by the cosine of angle C. So this is the addition. This addition here is what allows us to find a third side length given any triangle, or the Pythagorean theorem. In its definition, we have to have a right triangle. So the law of cosines is simply this, you could say extended. So this is if I wanted to find length C. If I want to find length A, I just move letters around. So it's going to be C squared plus B squared and minus 2 times C times B multiplied by the cosine. This is very important. Whatever side length I'm finding, the angle will be found on the other side. So if I'm finding length C, then angle C should be on the right side. So if I'm finding length A, we should be taking the cosine of A. And then we have length B would be A squared plus C squared. This would be multiplied, or minus 2 multiplied by AC cosine of angle B. And this is the law of cosines. We really don't need to know each of these versions. It's just a couple of things. Whatever length that we're finding, its angle must be on the right side, and also that length will not appear on the right side. You're probably wondering, well, if I'm finding this length, how would it appear on the right side? Well, there is one circumstance where we could possibly know this length and maybe not something on the right side. Okay, so the requirements for law of cosines for us to be able to use it. Okay, so we've examined when we're able to use the law of sines for the angle side angle and the angle side situation. Here for law of cosines, we're able to use it given these two. So already have seen this configuration within geometry. We know that SAS represents that we have two sides with an included angle. Included meaning is the angle between. And SSS represents that we have 3 side lengths. Okay, so given these two situations, we are able to use law of cosines to find additional information. So let's look at our first example. Slide this up, and there we go. So let's imagine we have this figure. We have 2 side lengths and an angle measure. So hot tip number 1, identify what you're using and what you're using it for. So we are using this, looking at this figure, we have side angle side configuration. Someone uses some abbreviations. So with side angle side configuration, we're going to use the law of cosine to find the third side length. All right. So law of cosine to find this third side length. So setting this up. So we desire to know what length A is. So we would have A squared equals, we have our two side lengths, 12 squared plus 19 squared, minus 2, and then the product of those two side lengths, 12 times 19, multiplied by the cosine, always cosine, of the angle opposite of the side we desire. So it'd be 54 degrees. Okay? And then the solving process to this, we can type this whole entire thing into our graphing calculator, being that we do not have a single variable within here. So in our graphing calculator, what we find is we get 12 squared plus, important we type in minus at this point, minus 2, because a common mistake is I'll see people put negative 2, so it is subtraction. And then cosine, yes, we're in degrees, so I'm good, of 54 degrees. And we get approximately 236.9699. This is a square. So as before, even with the Pythagorean theorem, we had this one thing at the very end, we have to square root. And when we square root this value, we find that we get approximately 15.3938, and our units would be centimeters. Okay, and it is just that law of cosines. When we have a side angle side configuration, and when we're finding the third side, it is that simple. We plug everything into our formula, a squared plus b squared minus 2ab cosine of the angle. I'm using different letters, but it is that, where 12, 19 squared, the product multiplied by 2, cosine of our angle measure. And yes, in this configuration, we'll always have that angle measure. Yes, in this configuration is always cosine, hence law of cosine. So let's look at another example. So what if we have this? So based off that first example, I encourage you to pause now, set it up, and solve. All right, how'd you do? So we set it up, noticing that we have 15 and 8, so 15 squared minus 8 plus 8 squared minus 2 times 15 times 8, cosine of our angle measure. So we placed all this into the graphing calculator at once, and it evaluates it to be 75.1584. We square root that value, and we get approximately 8.6694 meters. So we identified that it's side angle side. So law of cosine, law of cosine, law of cosine, to find the third side length, guys. Because there will be times where they won't really tell you how to begin. So here, I kind of told you that you need to find this side length first, okay? But in any situation, if you're using if you notice that you have side angle side configuration with your triangle, law of cosine will be your first step to find the third side. So what if we need measure of angle A or measure of angle C? So what if that's our situation? So here's what we do if that's the case. I still needed to find my third side length, okay? But if I need to know what the measure of angle A, what the measure of angle C is, the very next thing we do, I'll write it up here, okay? Actually, let's write it down. Move this up. Let's do it. The very next thing is we use the law of sine for the smallest, or I'll say the medium angle measure. Okay, so once we found the third side length, we use the law of sine for the smallest or medium angle measure. I say medium angle measure because we might already have the smallest. So how do we know what the smallest angle measure, the medium angle measure is? Well, the shortest side, because by this point we'll know all three, the shortest side will be opposite of the smallest angle. And the longest side will be opposite of our largest angle. So if I'm finding the smallest side or smallest angle, I need to look at the smallest side and it is opposite of that. So knowing that, I'm going to quickly draw just a miniature version of our diagram. Okay, so we have 8.6694 and 15, so okay. So we already know that this is 27, all right. So the shortest side, 8, tells us that angle A is the smallest angle, followed by would be angle B, and then the largest angle must be angle C because it's opposite of the largest side. So it increases here. So we have the smallest increasing to the largest. So law of sine to find what will be angle A. Okay. So we have, let's doing this. We have sine of angle A divided by its length, and sine of angle B divided by its length. Okay, so in doing so, in solving this, we know how to solve this. At this point, we cross multiply. We get sine of A to equal 8 times sine of 27 over 8.6694, which says sine of A is approximately 0.4189. Okay, so we need to find the angle measure. That gives us arc sine of 0.4189. Evaluating this, so arc sine, inverse sine of 0.4189, approximately 24.7652 degrees. Show that again. There we go. So we have our second angle measure. So this is measure of angle A. So now we need the measure of angle C. So we've used law of sine to find the shortest or smallest angle. Next, the last thing we do, box this off. Now that we have two angle measures, what can we do to find the third? Well, we take it away from 180. So I'm going to put 180 minus. So we take 180, we take away the measure of angle A, take away the measure of angle B, so that we've taken away 24.7652, and taking away the 27, measure of angle B. When we do that, we get roughly 128.2348 degrees, and that is again the measure of angle C. All right. All of this, you're really going to have to ask whether or not you need to do it. Most often, one of the key words that will tell you that you need to do all of this is if you hear the idea of solve the triangle. That means to find every missing piece. Okay? Moving on to our next example. So what if we have no angle measure at all? How do we approach this problem instead? So if we have a side configuration, the very first thing that we're going to need to do is, using law of cosine, we will find the largest angle first. Okay? So we have all the side lengths, so we need to find the largest angle. The reason for the largest angle, law of cosine will recognize obtuse angles. If you think back to the range of not range but domain of the inverse cosine and inverse sine, inverse cosine went from 0 to pi, whereas inverse sine went from pi over 2 to negative pi over 2. So inverse cosine, when we use the calculator, it will recognize an obtuse angle, whereas inverse sine will not. All of that to say, cosine recognizes obtuse angles, so we find the largest angle with law of cosine on the off chance that our largest angle is obtuse. It might not be, but off chance it is. So we have angle A here. Yep, angle A is the largest angle because opposite of the largest side. So largest side is 19 centimeters, which would tell us that the largest angle is angle A. Okay, how does the law of cosine change here? We have all three side lengths. I do not know the angle measure. So you know how our unknown value is on the left by itself? Well, here our unknown value will be the angle measure within cosine. So I'm finding angle A, so length A has to go alone. Finding angle A, so length A has to go alone. Then we have 15 squared plus 17 squared minus 2 times 15 times 17. Cosine of angle A. And I'm going to use this nice little technique that we have seen before when dealing with trig identities, is I'm going to replace cosine of A with a single variable. And once I solve for that variable, I'm going to plug cosine of A back in and solve there. But before I do that, I just want to make this note that the length opposite of the desired angle is what must be placed alone. It must be placed alone. So we're looking for angle A, so length A must be placed alone. So now, rewriting this. Okay. And rather than writing cosine of A, I'm going to write here U. So I'm going to solve for U. Once I get U alone, isolated, I'll place cosine of A back in. So solving this. If I type this into the calculator, we should get 514. 19 squared is 361. Okay. And then we have placing this in. So negative 2 times 15 times 17 will get negative 510. If you would rather just think 2, positive 2 times 15 times 17, and then know that you always subtract, that will work as well, because a mistake I'll see sometimes is when computing this part, people will leave off the negative and then the right plus here. This will be subtraction. It should be subtraction. So now we solve further. Oh, we have a two-step equation. That's nice. So we subtract 514. Oh, we're going to get a negative value. That's okay. So we get a negative value. Drop down, negative 510. All right, and we divide. So when we divide by negative 510, we get approximately, actually exactly, oddly enough, exactly 0.3. That's equal to U. We finally have U alone. So now I'm going to come back up here and say 0.3 equals not U, but I'm going to write it as cosine of A again. So let me just mark this. So I took cosine of A and wrote it as just U, so that when I solved for U, I placed cosine back in. So now we need to take the inverse cosine, arc cosine of 0.3, and what we get here will be the measure of angle A. So doing so, we find that we get the measure of angle A. Let's see. arc cosine of 0.3 gives us approximately 72.5424 degrees. Okay, so it's not as quick as the side angle side configuration, where we pretty much have everything on the right and just we have to compute it. Here we do have to do some algebraic manipulation to solve for u, and then take inverse cosine of that value that you get. So we get the measure of angle A now. So what if we desire other angle measures? So given that we have all three side lengths, what if we don't want the largest angle measure? We're going to take the exact same approach as we did with the previous example. We take the law of sine and we use it for the smallest or the medium angle measure. Okay, so I'm going to draw real quick a rough model of our problem. We just found angle A to be 72.5424. All right, so the smallest side length is 15, so the smallest angle measure is 2, which will make our setup sine of C. I said 2, the smallest angle is C. Sine of C over 15 equals sine of 72.5424 over 19, which gives us sine of C to equal 15 times sine of 72.5424 divided by 19. When we evaluate that, we get approximately, because remember, parentheses, and parentheses, all about parentheses. We get, when typing this in, can you see it? Yes. 15 times the sine of 72.5424 divided by 19. We get approximately 0.7531. This is the sine of C. So we take the inverse sine of that now, which gives us approximately 48.8596 degrees. That is the smallest length. And now our third angle measure. To find our third angle measure, our last angle measure, move it up, we take away from 180. So we have 180, we take away the 72.5424, we take away the 48.8596, and we get approximately 58.5979 degrees. And this will be the measure of angle B. So again, a little bit of a lengthy problem, but ultimately not that bad as long as we follow these guidelines. That law of sine cannot be used until we find that first thing. So let's summarize. So solving triangles. If we have side angle side configuration, what do we do first? The very first thing is we use the law of cosine to find the third side. Okay, so first thing for side, use law of cosine to find the largest angle measure. Second, so in both situations, the second thing is the same thing. So once we have found the third side, once we have found the largest angle measure, we use law of sine to find the smallest or the medium angle measure. So that's the same for both of these. Once you've taken that first step, it's the same. And then third and last, because by this point we would have all three side lengths and one or two angle measures. Actually, by this point we'd have two angle measures. We would, at this point, third and last, is we do the 100 minus. Okay, so this is our setup. This is our guide that will take us through solving triangles, and this is for the two configurations. For angle side angle and angle ankle side, those you just use the law of sine the whole way through to find all of the side lengths. Okay, so best of luck to all of you while you go through the practice here, and I will see you in the next video where we start applying this law of sine, law of cosine to actual real-world problems and application techniques. See you in the next video, guys.